Hello, everyone. I hope you all are having an exciting and engaging time so far in ICE 21. I am Viresh Wali, Senior Specialist Platform, along with Thanumoorthy Sundaresan, Head of Engineering Global Delivery, and we are here to present a talk on automated web validation in fragmented services ecosystem. I'm sure everyone has faced their shares of troubles with release validation and build certification processes. Saying that such a process is consistently smooth would be an understatement at best. Release validation in fragmented services ecosystem cannot be safely pursued with existing monolithic QA practices and strategies. We believe an engineering tool is necessary in today's cloud native landscape to provide better insights and help us make confident decisions about the stability of our production releases. This talk aims to provide one such simple, practical, and tangible engineering idea. I hope you all enjoy it. As we move ahead with the talk, I request you all to add your questions in the chat section and we'll try to cover them as we progress.
Thank you, Viresh. And if you're wondering, this is Tanu, the same person whose photo you saw in the previous slide. That was a fantastic presentation before Sheldon. And I ask all of you to shift gears, be a slightly different problem. I'm sure it's going to be a relevant one. Let me walk you through the agenda. We will start by talking about the problem statement, which, as Viresh pointed out, it's about build validation, something all of you, I'm very sure, can relate to. More on this later. And we will talk about microservice ecosystems, how microservices brings in an additional complexity to this problem statement. We'll also talk about what are the opportunities that we are missing as part of build validation. Finally, Viresh is going to talk to you about our solution to this problem with a demo. We'll also talk about the design for the solution, and we'll end with key benefits and our future vision. And of course, followed by Q&A. All right, these are the questions that all of when especially when you're trying to get a new build to production, when you're trying to validate the build, whether it's fit for production. What kind of data should I use? And should I use production data to validate my build, or can I use some mocked up test data? What kind of testing should I do, and where do I do this testing? Should I do it in let's say in a blue-green type of production environment, or should I do it in a bespoke test environment? Most importantly, what does a good build validation or certification looks like? Is it okay if I just look at the test cases that I have, manual or automated, and see if the test cases pass? Or should I also look at other information that my new build provides, for all to see, like logs? What about APM metrics? What about errors that you see in, that your application provides? Well, of course, we ask all these questions expecting we have fast, stable, predictable production release. The reality is more often than not, that's not the reality that we see. Now, the complexity increases considerably when you bring in a microservice, layered architecture. Well, microservices brings in a much needed but complex fragmentation to your application ecosystem, all for the right reasons. Now, with microservices comes a need for better observability, knowing where your microservices stand, looking at the logs, distributed tracing, application performance monitoring metrics, to name a few. But most often than not, we use these matrices to kind of troubleshoot any issues that you see in production. It's kind of a reactive monitoring that we do. This is, and I look at my logs and I see an issue in production to find out, okay, what the issue is, to get a little bit more insight about that particular issue that I see in production. But what we feel is these logs offer a lot more insight when you are in your build validation phase also, when before you take your application to production. We call this proactive monitoring. From the logs, looking at the logs, looking at the APM metrics, looking at the infrastructure state, the logs that I see, decide more accurately about the quality of my application. Because we feel that is a missed opportunity. All the tests that we do, system, load test, security test, all that we do to certify a build in a pre-prod or maybe a blue-green environment, provides you only a part of the information about that application. The other insights that you can gain from the application are all hidden. The logs that the application provides, the system logs, the network logs, application performance monitoring metrics, infrastructure logs. These are all hidden. We typically don't look at these logs to decide or certify our the quality of our build. Why? Because it takes, we have seen from our experience, it takes 3 times more to analyze your logs as part of your build certification compared to just using your test case validation process. It's purely a time equation. So what we thought is, this is a good problem statement, and we looked about automating this whole, build a log validation or log analytics based on logs. And Viresh is going to talk to you about this. So I'll hand over to Viresh.
So how do we solve the problem of time erosion and manual toil in analyzing the release? How do we make the testing and release exercises more fruitful for the dev teams and for the business stakeholders? The need is to devise a better approach to release validation while still minimizing friction between teams, retaining the APM and logging tools that they are comfortable with, and keeping the overall process and solution simple and palatable for everyone. We can achieve this by building an SRE-oriented build validation solution platform. This platform, in its essence, will gather all relevant facts from common APM tools and log aggregators that we use in our project. We all deeply rely on such tools in our production or non-production environments, and each of these tools offers their event data as standard REST APIs. So while our end-to-end test cases and integration test suites, or maybe even traffic mirroring, running there, this solution would collect the APM and log data, aggregate it, massage it, and transform it as required. The results of such transformations would be new cross-cutting metrics and SLIs that provide us better insights into what our applications were doing at that point in time. This solution also allows us to relate the data and events from two or more APM tools and build some coarse-grained inferences out of them. This is something that we all desire, but often we don't pursue it because it is predominantly a manual exercise within our project teams right now. For example, we could relate the error rates in App Dynamics for an application to the exception counts and unique exception names that we see in overops for the same application. Or maybe you could group the exception messages or call traces in our logs based on a common class or a method of interest. These kind of cross-grained inferences, they create a differential value in how we look at our errors and the causes in our application. Comparing these types of metrics between two releases of a microservice or even between two different environment stacks like blue versus green could surface potential insights at the click of a button. All these new derived metrics can be visualized as standard SRE-based dashboards in a Prometheus Grafana setting. This provides us with a way to standardize our testing strategies and also provides us a unified approach to how we analyze and measure the health of our applications, irrespective of our services, teams, and projects. So I have a unified mechanism, a unified yardstick to apply to the entire stack, entire team, entire project that we have. Let's check out a quick demo of the build validator and its visualization. Our use case is that we have a new blue release that we want to test for production fitment relative to a current production green or live release. So an end-to-end test suite or a integration test suite is running on blue release, and the build validator is gathering error facts from the overops for both the blue and the live release. So what are the objectives of this demo? First is standalone error analysis views of each of these releases. So we'll see types and volumes of errors observed on the two releases individually. Then we'll also check any regression sources in form of any new errors that have been surfaced in the blue release and any existing errors that might have been subsided there. Then we will see some comparative error analysis between the two releases. The live release data will serve as a control benchmark for us, and the new blue release will be the validation source. Some example of analysis that we might touch include seeing the rate of increase or decrease of errors based on error names, their volumes between the two releases. We will also see a tabulated view of errors and how their volume is changing as a relative percentage between the releases. Then we shall see the rate of change of errors based on class or method names to help us better understand the code classes that are actually contributing to those errors, the sources of errors. Then we'll also look at the timeline graph of the errors as the test has been progressing. The timeline is really interesting in a manner that it shows you how error percentages are changing as your test progresses. New lines that start on the graph might actually signify new errors that have surfaced in your blue release. This way we can use the time from the graph to cross-check your service logs, your APM logs, or whatever observability tools that you have at the back. And this gives you something concrete to actually start your more finite and fine-grained detailed analysis on. As you can see, this type of analysis is particularly the need of an hour, but we seldom actually pursue it because we don't have a straightforward path towards it. Let's check out the demo video and see how the dashboard actually looks like. So we have two releases here, Hybris API, Hybris Radar. One is blue, one is green. This job is pulling data from overops every 62 seconds for both of these releases. We have processors here which define the logic of our testing strategy. They are grouping based on error names and class names. And the fine defined cross-grain metrics are logged here in the application. Same data is visualized in a Prometheus Grafana set. This is Prometheus. These are the list of fine metrics that we have actually derived from the overops. This is one of the metrics and how it looks like. You have a blue deployment, you have a green deployment or live deployment here. We are comparing two deployments in this case. And this is the name of an error that has happened with a count of how much that has been seen for it. Let's see what Grafana looks like. This is the standard dashboard for this application validation. We have two releases, blue and green. We have filter drop downs for it for you to choose what you want. Groups of these graphs define the standalone analysis, potential regression candidates, a comparative analysis, and the same kind of comparative analysis, but grouped by classes and methods. Everything in the last two sections is based on blue versus green. Let's see what standalone analysis looks like. So you have a tree map of top 12 errors that has been seen in the blue. You can see the name for it, the weight for it. This is within the time range of last 5 minutes since the test. The right hand side actually shows you the tree map for green release that you are running. The donut shows you the weighted percentage distribution of particular errors that has been observed in your releases. Each of these graphs does a standalone analysis of your release. It doesn't compare anything. The graphs here actually do the error analysis, but based on the source of errors. It gives you a view into the classes that have been throwing those errors in your application. It's possible that the first class here is actually contributing the most amount of errors, model not found exception in this way. So have something to start relating your code and errors with. All of these dashboards, all of these graphs that you see here are standalone. Let's see regression candidates that we have. So you can see you have 35 new errors that have surfaced in your blue release, and the right-hand side panel shows you the names of those errors in red. These errors are not there in live, and it's probably a code change or something that has been, reverted. It could be a regression source that you need to look at. But the list actually helps you to dig down what you might want to see. The 10 errors are something that has been rectified in your blue. You are not seeing these errors in blue anymore, but they still exist in your green. So this is the good side of things, the actual code change that is being directed towards it. The table here shows you the quantitative analysis of a particular error based on what was happening at that point of time. It shows you a difference in the count between two releases and the percentage change of it. So you can see model not found exception actually jumped substantially. You see a 99% increase in it. Similarly for other ones, and this one actually has gone down considerably. The code changes might have actually fixed the problem that you were looking at. And in case you want to focus on one particular at a time, just in case you have a hot patch kind of a release, you can drill down to that error and you can just focus on that thing. The graph on top of this is actually interesting. There is a timeline graph out here. So it shows you the errors. For example, this one, attribute not found, it actually went down considerably from 89 to 20%, then jumped up a little bit. Then you also have two new lines out here. They were not there. They suddenly started showing up on the log. So you bring this graph and the timeline overview. You can actually use this data, the name of your error, and then can go and dig in your application log to see what might be happening there. These graphs present the same kind of data to you, but with a different view perspective. So these are showing you the errors based on the sources of those classes. You have class names, method names here, and the grouping is tactically same. You have a percentage increase or decrease of the errors seen in a particular class. So I might give you an idea about the sources of those errors, the classes that are actually contributing to it. All of these dashboards and graphs are grouped clean in a clean and perspective manner, and you can use this thing as a standard SRE-based dashboard. You can add alerts to it, you can add benchmarks to it, and you can use this across every team, across every application, even at a highest level, in your application testing strategy. So you want to do the testing for a whole microservices ecosystem, or you just want to concentrate on a single service at a point of time. Same dashboard can serve all your purposes. This is what the high level component architecture of Build Validator looks like. The platform itself provides a set of core framework components and expects the teams to develop executable plugins based on their respective validation strategy. Technically, the Build Validation platform is a Spring Boot reactive application. The validation plugins are executable Spring PF4J plugin components. These independent plugin jars can be plugged into your platform and managed as needed. Each plugin has its child application context and child class loader that attaches to the platform's parent application context and class loader. This keeps the plugins mutually exclusive to each other while still allowing them to reuse the platform's core components and Spring Boot. The solution offers numerous reusable components like distributed IMDb caches, scheduling services, metric registries, API and log connectors. Teams developing validation strategy plugins can pick and choose the components that interest them based on their own use case flows, the way they want to test their strategies out. So while the platform provides you the core component skeleton and the functional features, the teams can extend by actually applying configurations on top of them. So you might have your own APM keys and tokens. You might prefer a different REST transport format, a different scheduling interval, or maybe a different cache details based on your testing strategy. This way, your teams can extend and customize the core components of the platform for their own intended event data sources and REST. It is also possible to develop polyglot plugins using non-JVM based languages like Python, JavaScript, or even Golang. These can still run on the core platform by leveraging JVM scripting engine extensions like Jython, Nitron, J2V8, or even with the plain JNI. So while the platform manages the lifecycle concurrency and multi-tenancy for your deployed plugins, teams can focus on building their process-specific validation strategy logic, deploy it as plugin codes, plugin jars, and just manage it themselves. All this makes the design clean, pluggable, and extensible as the teams have full freedom to implement their own validation strategy. This architecture is also inherently stateless as it doesn't store any data of its own. Based on how plugins are constructed, it consumes streaming event data from your APM and logging tools and reactively publishes those metric streams to Prometheus and Grafana. This allows the whole core platform to be deployed in an infrastructure agnostic manner. It can run on any cloud provider that you prefer, either on managed virtual machines or on orchestrated platforms like Kubernetes or Apache Mesos.
So this whole product got built, when we were looking at solving our automated testing problem. And during Gaurav's presentation earlier today, we did something called as traffic mirroring, which automated our testing, completely using production load. But after that, we realized that while our testing is automated, testing and load generation is automated, validation is still manual. So that's when we kind of started looking at automating our validation process also. We came across this product. Through this, we realized that it is just not something that kind of goes along with traffic mirroring. Logs offer tremendous insights, which if you automate and if you make that analysis of logs automated, you can get significant insight at a very short time. So we thought this can exist as a standalone product paired with any type of testing that you do. So what did we see as benefits? Of course, quality in production considerably. And of course, this increases the probability of our releases because we do these insightful validations much ahead in our the life cycle of the product. And of course, this reduces time to market considerably because we expect close to about 70% of our analysis time going down because of automating through this product. And of course, this results in improved confidence on your build and release cycles. Where do you want to take it next? We want, of course, to continue building more pluggable extensions. We have few built already for the logs and the APM tools that we use, but we want to build more. We want our reporting to be a lot more intuitive, navigatable. We want to see, your test execution, for example, alongside these logs and APM analysis, all in one dashboard, so that you can correlate a particular test case execution to an increase or a decrease in our error rate in your logs. And of course, we want to make it open source so that other teams can come in and build their own plug extensions for the logs and other tools that they're using, logging and APM tools that they are using. And over to you again, Viresh.
Thank you, Thanu. We can now talk about any questions or queries if anyone has, but I'm not exactly sure if we have the time left for it. But you guys can always, post your questions in the chat section. I'll take time to answer them. And you can also reach out to the core team members here on their email IDs for a more detailed discussion if you want.
I think this was quite innovative and useful, Thanu, Viresh, and it's open for questions. Anyone has any questions for both of you? Going once.
Yeah, I hope the topic was not too advanced for anybody out there. It doesn't seem like that, yeah?
I'm sure we've had enough flavors of
Yeah.
variety of exciting innovations. I think it's just there, another interesting thing. But one question on the chat, Viresh, when are we inner sourcing it?
Very soon this year, hopefully in Q2, early Q2. We wanted to finish adding few additional plugins that we are building right now. And then, on the next, and we are having conversation with our client already about making it as a inner source product across Sapient. So we are expecting that early Q2 is when we'll be inner sourcing it.
Great. Going once.
Thank you.
Going twice. Going done. Thank you, Thanu. Thanks a lot, Viresh. Have a wonderful rest of the day, both of you.